Hello, welcome to the video. Today I'm just going to go over a synthesis example from Chapter 11, which Chapter 11, as you know, is focused on alkynes. This is a synthesis question. I would rate it as a relatively difficult test-like question. Just synthesis questions in general, I think one thing I'd note that it is usually helpful to work backwards. And who knows, and forwards, but not exclusively forwards. Working backwards can be really helpful just to kind of get you going. So as far as why do we work backwards? We work backwards because sometimes it's hard to see how a starting material really can connect with the final product. Versus if we look at the final product, we might get some pretty good clues. So for instance, this final product is a ketone. It turns out that right now where we are in organic chemistry, we only know one way to synthesize ketones. The only way to synthesize ketones is by hydration of an alkyne. So we would then know that we can work backwards to an alkyne, and we're going to hydrate that alkyne with sulfuric acid and water. And you can potentially put in the mercury reagent as well. So those are the hydration conditions to go from an alkyne to a ketone. And essentially, we have to still synthesize the alkyne. That might seem like a challenge, but right now, if you think about alkyne synthesis conditions, all of them have a dihalide of some sort. So essentially, we're going to have to convert this into some type of dihalide, and the one that is possible is if you have a dibromide like this. So if we have our dibromide, we can treat this with a strong base. We can either use potassium terbutoxide in a polar aprotic solvent, or we can use sodium NH2 and ammonia as the solvent. So sodium NH2 and ammonia as the solvent. We'll do a double elimination of this starting material to provide our alkyne. We still need to get the extra bromine on here. How do we do that? We can only add bromines like this in addition reactions. Addition reactions require an alkene or an alkyne. They require some type of pi bond. So we have to get this to have a pi bond for us to be able to add our two bromines. Again, we could work backwards and say, how have we put two bromines onto a molecule? We've done that from an alkene by just adding Br2 to that alkene. How do we get from here to here? That's just an elimination reaction. Again, we can use our big bulky base in a polar aprotic solvent like DMSO to do that single elimination to form the alkene. So again, this is probably a hard-ish question. It was 1, 2, 3, 4 steps, so not a terribly long synthesis question. How can you really train yourself to do these questions? One thing I mentioned earlier is like right now we only have one way to make ketones, and that kind of brings up something that really successful students do in organic chemistry is make reaction sheets to organize the reactions for themselves. So for instance, right now we might have a piece of paper, and this is our reactions sheet that says ketone synthesis. So on the ketone synthesis reaction sheet, we'd have ketone synthesis, and somehow we're making some type of ketone. The only way that we can do that right now is by starting with some alkyne and then hydrating that. So HgSO4, H2SO4, water. That is our only ketone synthesis method. So why is that helpful? That's helpful to organize your reactions like this, because when you see a ketone as the final product, that makes it really easy to work backwards. So you should be organizing those reactions by what they synthesize, so that you can kind of have those in your noggins. Other thing I'd mention is I've seen students do things like this, where it's like, oh, we just need to add a bromine, Br2, because they're like, oh, I remember that bromine as a reagent adds bromines to stuff. But this won't work, right? We have to have electrons on this molecule to somehow get from here to there. We need a pi bond to do that. So how would you know that this is not possible? Other thing that's really important to focus on is mechanisms. If you tried to draw a mechanism for how this molecule adds a bromine in that position, so just by Br2, you wouldn't be able to do it. So when you focus on mechanisms during your study of organic chemistry, that allows you to be able to answer the question of why won't that work? And then ultimately, when you're able to say why won't that work, you have an easier time deciding what will work. So those are some things to focus on. Hopefully this was not only helpful for this synthesis, but also just helpful in general in studying and how to kind of approach these questions. So, all right, I'll see you guys Wednesday or sometime. Yeah, maybe earlier, maybe later.